I don't know, just making this up. Let's do negative 2x cubed plus 1. Negative 2x cubed plus 1. What is always step number 1? Base graph. So take away the numbers. What's left? Correct. So draw me x cubed. What is step number 2? Identify or describe the transformations, going inside the brackets first because of bed mass. Inside the brackets means it's horizontal. Multiplication means it's a stretch or compression. Whole number means it is compression. xy goes to 1/2 x, or x divided by 2, whichever one you prefer, and y. Okay, so that's number 1. Going outside the brackets, we have a multiplication by -1 and an addition. What's going to come first, multiplication or addition? Multiplication is going to come next. It's outside the bracket, so it's vertical. And multiplication by -1 means it is a reflection. xy goes to xy goes to. So vertical, does it affect the x's or the y's? Y, so the x's isn't going to change. What's going to happen to the y's? Negative y. And the very end is going to be our plus 1. Outside brackets or inside brackets. So that's a vertical translation. 1 unit. Up. Okay, so starting with our compression, if you're a point person, on the scrap piece of paper or wherever you have room, you can draw the points and then divide the x's by 2. I'm going to do it for the visual people who can just see it, and I'm going to show you the ruler trick that we did with reflections, because I think this might help some of you. Okay, so the very first point I'm going to go to is our -2, -8. Because this is horizontal, I don't want it to change up and down. I only want to change it side to side. So what is the current x coordinate? -2, and so we're going to divide by 2 or multiply by 1/2, whichever way works for you. So -2 times 1/2. So what I'm going to do is put my ruler on it horizontally because I don't want to move it up and down. So sometimes the ruler helps people to not shift it. So -2 is going to go inward toward -1. Okay, going up to the next one, the current x value is -1 times 1/2. -1/2. So again, putting the ruler horizontally stops you from moving it up and down. 0 times 1/2. 0. 1 times 1/2. 1/2. And 2 times 1/2. 1. Okay, so we had done the ruler trick with reflections. Sometimes it works with certain people's brains with stretches and compressions. Okay, join those points. Did we do a horizontal compression? Did we squish this in towards the y-axis? Yes, we did. Okay, again, if you're a point person, you can just continue on with the points. I'm going to go back to the ruler trick for the vertical reflection. So I'm going to the first point on our second graph or our new graph. Again, putting the rule vertically is going to stop me from moving it side to side. Okay, right now y is at -8. It's going to flip up to +8. I'm at the blue graph. Yes, it's always just the previous graph you're going to, not the original. Okay, going to that point, we headed a half -1. -1 is going to become +1. We love the origin because it doesn't change. Fourth point was at a half 1. The 1's going to become -1. And the last point was at 1/8. 8's going to become -8. Okay, so here's our reflection. Did we do a vertical reflection? If you look from the previous graph to this graph, did we flip it up to down? This one's a little hard because we've talked about cubic is actually the same as a horizontal reflection, so it could look like that as well. No big deal. Now I'm going to take every point, and what am I going to do?
So you're saying you really don't have to do the points, and if you just knew how to draw the same thing backwards, but not making a mistake, you're fine.
Okay, last graph's in red, and what are we going to do with it? Just move it up 1. I did go up 1. Who likes the ruler trick? Whose brain does that work for? Okay. Okay, let's do a horizontal one. Let's do a square root. They're pretty. So square root of half x minus 1. We will in a second. I'm just going to do base graph first. So strip away all the numbers. If you need to still look at that cheat sheet, look at it. What base graph are we dealing with? Square root. So draw me a base graph of a square root. Okay, so swoop to the right. Okay, describe the transformations. What was the little trick we talked about yesterday with HCs, HSs, HRs? You're going to factor. Now you need to be careful here with your factoring because we're taking out a half. So we're going to have to divide each of these by a half. So a half x divided by half, not bad. That's going to be x, but be careful here. So 1 divided by a half, you're going to flip that bottom fraction, gives us 2. Okay, so sometimes your brain's going to think 1 divided by a half is a half. Okay, it's not, it's 2. So that's going to affect your translation there. Multiplication comes first. It's horizontal because it's inside that square root or inside those imaginary brackets. A fraction is a stretch. So this is the first example we're doing with a horizontal stretch. What do we do with the x value? Divided by the value So we get x divided by 2. Well, we'd never leave it like that. What is x divided by a half? It's 2x, and that's why it's a stretch, because every x value is going to be twice as big. Okay, minus 2 is inside bracket, so it's a horizontal. Subtracting 2 means it is a translation. 2 units to the right. If you're a point person, do the points. I'm going to do it more visually because that's what people are struggling with. And I'm going to start with the first point, which is 0. So 0 times 2. The next x value is 1. 1 times 2. And again, purpose of the ruler is just to stop you from moving it up and down. The next x value is 4. 4 times 2. The next x value is 9. 9 times 2. Right off the grid. So we're just going to forget about that last one. Pause and look. Did you grab this thing by the side and yank it away from the y-axis? Did you stretch it horizontally? Now we're just going back to that new graph, so the second one for us, and we're moving it over 2 points. So counting 2 to the right, 2 to the right, 2 to the right. The last example, is there anything particular you want to practice? Nothing? Okay. Let's do an absolute value. Why not? To absolute value, negative x. Okay, so draw the base graph. So what does absolute value look like? Sorry? Usually a half mark or a mark depending on the question. Okay, identify the transformations. We're going to go inside the imaginary brackets first. Okay, inside means it's horizontal. A negative means it is a reflection. XY goes to going outside of that absolute value, so that is a vertical something something. Multiplication by 2 means it's a stretch or compression. Whole number means it is stretch. XY goes to Okay, so let's do the horizontal reflection first. Again, I'm putting the ruler vertical just to stop us from moving it side to, or moving it up and down. Okay, so the first x value is negative 2. Negative 2 is going to go to 2. Next one's negative 1. Negative 1 is going to go to Next point is 0. Next point was 1. It's going to go to, what do we see that's happening here? It's the exact same. So to show that, you can either leave it, or if you like using the colors, you can use the second color just right on top. Okay? If colors aren't your thing, then don't worry about it. Okay, so that tells me you understood there was a horizontal reflection, just this one didn't happen to change. Okay, our stretch. Okay, so the first y value is 2. It's going to go to 4. Okay, again, the ruler just stops us from moving it side to side. The next y value is 1. 1 times 2, 2. Zero times 2, 1 times 2, 2 times 2. Thanks for carrying that one, Noah. Okay, stop and ask yourself, did we do a vertical stretch? Did we grab the top of this absolute value and yank it upwards? There we go. Questions?